Welcome back, everybody. Let's do another example of a post-test using Fissures LSD, also known as protected T. We're going to revisit ANOVA example number 2. In this example, we are looking at 3 different groups of patients who suffer from schizophrenia. We were giving them 1, 2, 3 different levels of a drug, hoping that that drug would allow them to better concentrate. And their concentration scores did improve when we look at the different levels of the drug. And that resulted in a statistically significant result. You can see the F value is 9.14. 9.14 does exceed our critical value of 3.88. So we have a statistically significant result. And that means we are cleared to do the post-test. So now we want to figure out which of these groups differ from one another. Does the 10 milligram group differ from the 100 milligram group? Does the 100 milligram group differ from the 500 milligram group? We are going to compare all pairs. In other words, we will do pairwise comparisons. We need to determine if post-tests are necessary. Yes, they're necessary. Anytime we do an overall omnibus ANOVA and we have 3 groups or more, if we find statistically significant differences exist, now we need to do the post-test to figure out where those differences are. Let's go back and look at the means and figure out which groups we want to compare first. I want to look for the biggest difference that exists. I see a difference between the 10 milligram group and the 500 milligram group is the biggest difference we have. That's a difference between 6 and 1 on that measure of concentration. Let's compare those 2 groups first. So this section makes that clear. It says first, compute Fissures LSD for the 2 groups with the largest mean difference, 500 milligrams versus 10 milligrams. All right, let's figure out this critical value. Coming back here, we're going to focus on degrees of freedom within groups. That's how we figure out the critical value for the t-test we're about to compute. That t-test will have 12 degrees of freedom. Let's go ahead and look that up real quickly. So here's a t-table. We will remind ourselves that this is indeed the t-table. We're going to do a two-tailed test with an alpha of 0.05. We have 12 degrees of freedom. Right there is our critical value, plus and minus 2.179. All right, let's go back to the post-test. Now we know the critical value. Now we want to compute the t-value for Fissures LSD. Remember, we are comparing 2 means. So going back again, we can see the mean for the people taking 500 milligrams is 6. The mean for the group taking 10 milligrams is 1. So we are comparing 6 and 1. We're going to find out the difference between them. Of course, that difference is 5. Now remember, in our formula, we're going to take mean square within groups and put that in the numerator of each one of these fractions. So I come back and I just look at my ANOVA calculations. And mean square within is right over here. Remember, that's variance within groups. And I can see that equals 3.83. So I come back to our equation. I'm going to put 3.83 in each one of these numerators. I need to divide by the number of people in each group, and we had 5 people in each group. So let's do the math real quickly. We'll take 3.83 and divide that by 5. I like to work out each fraction independently and then add them up. So this fraction right here equals about 0.77, and this is the exact same fraction, so we're left with 0.77 plus 0.77. A little bit of rounding as we go is no big deal. It's better that we're all able to follow along step by step. So when we add up those 2 values, we get 1.54. I have to make sure I take the square root of that. So let me hit my square root key. That equals 1.24. So now we're left with the difference that we see, 5. There's a difference between those 2 groups of 5 points. And we're going to divide that by differences we expect by chance, which is 1.24. That gives us a t-value, in this case a Fissures LSD protected t-value of 4.03. We now want to compare that value with our critical value. If it exceeds that critical value, then the 2 groups we're dealing with differ statistically significantly. And of course, 4.03 does exceed 2.179. So we can say, let's go ahead and look back at the means. We can say that the people taking 500 milligrams had better concentration scores than people taking 100 milligrams of this drug. Our first comparison was looking at the two groups that differ the most. Let's look at the next biggest difference. The next biggest difference is between the 10 milligram group and the 100 milligram group. In other words, we'll be comparing a mean of 5 and a mean of 1. So this part right here makes that clear. We're comparing the 100 milligram group and the 10 milligram group. In other words, we're comparing the mean of 5 and the mean of 1. Keep in mind, this value right here, the denominator, it's going to be the exact same in all of our comparisons because we're using the same numbers, mean square within over the number of people per group. So as long as we have the same number of people in each group, all of these comparisons that we do will have the same denominator, this bottom part. You can see again, we just put 3.83 in, which was the value of mean square within, and we divided by the number of people in the group, 5 people. So now we have 4 divided by 1.24. Let's do that math real quickly. 4 divided by 1.24 equals about 3.23. Let's compare that value, our obtained t-value for Fissures LSD test. We'll compare that with our critical value. And 3.23 clearly does exceed 2.179. So we can say the 100 milligram group and the 10 milligram group differ significantly. And specifically, we see that the people taking 100 milligrams are outperforming the people who took 10 milligrams. The people who took 100 milligrams had better concentration values. So what's the next biggest difference? Well, the only other comparison that exists is looking at the people who took 500 milligrams compared to 100 milligrams. So that's a mean of 6 compared to a mean of 5. That's a difference of 1 point. That's not a very large difference, but let's check to see if it's statistically significant. So this is making it clear that we're comparing the 500 milligram group with the 100 milligram group. We are looking at the difference between a mean of 6 and a mean of 5, so our numerator, of course, equals 1. Remember, our denominator is the same because it has the same values that we used in the other two comparisons. So we're taking 1 and dividing by 1.24. Let's do that math real quickly. 1 divided by 1.24 equals 0.81. So of course that's a relatively small t-value. We're going to compare that t-value for our Fissures LSD post-test with our critical value of 2.179, and it does not exceed that value. So the difference between 500 milligrams and 100 milligrams is the type of difference we would expect to see just by chance. It is not statistically significant. So let's just summarize. We found that the people taking 500 milligrams have better scores than people taking 10 milligrams. People taking 100 milligrams have better scores than people taking 10 milligrams. But people taking 500 milligrams do not differ from people taking 100 milligrams. Do you see how this type of study is important? What we're learning here is we'd want to give people like 100 milligrams, but no more, because when we jump from 100 to 500, there's not really a statistically significant improvement. And of course, when we give people more of a drug, there is more of a chance that there are going to be side effects. So let's go ahead and write up the basics. So we'd say Fissures LSD test was performed to identify specific group differences, revealing that the 500 milligram group and the 100 milligram group outperformed the 10 milligram group. And within those statements there, I'd also list the results of the t-test. So remember, this was a t-test with 12 degrees of freedom. For the first one, we found a value of 4.03. So down here, I have t with 12 degrees of freedom equals 4.03. P is less than 0.05 because that result was statistically significant based on a two-tailed test. When we were looking at the difference between the 100 milligram group and the 10 milligram group, we found a value of 3.23. So down here, I listed t with 12 degrees of freedom equals 3.23. That result was statistically significant as well, so we have p less than 0.05 based on a two-tailed test. We typically only write the details of the groups that differ significantly, so this last comparison, the 500 milligram group versus the 100 milligram group, we don't necessarily need to discuss in our interpretation. Some people will write a final statement saying something like no other group differences were statistically significant, just to kind of sum things up. All right, so there's another example for you. We've got one more left. So in the next video, we'll look at example number 3. I'll see you in the next video.